We're doing a webinar here on the theory of constraints and lean by myself, Philip Marris. The outline is very simple. After a brief introduction, I'm going to summarize theory of constraints and then lean, and then I'm going to talk about putting them together, and then I'm going to give you a few examples and conclude. We're kind of hard to locate in terms of the kind of industries, the kind of people we work with, because we're very curious and we love working on new stuff and different stuff. So as you can see, we've done quite a lot in aeronautics, but we've also done quite a lot in the medical world. We've worked with companies such as McDonald's in their restaurants, Louis Vuitton in luxury goods, mining with iron gold and all that sort of stuff. So we work in basically any kind of physical product, and indeed we work in quite a few service industries also, in insurances and banks and stuff, but that's less frequent. Start with the theory constraints. The guy there is Elio Goldratt, who the author of the book The Goal and the creator of the theory of constraints. Probably one of his most brilliant ideas was when he was frustrated with regards to a number of people who understood the theory of constraints, was he wrote a novel, The Goal, back in 1984. I was working with him at the time, and I couldn't. He ran a software company selling finite capacity scheduling systems. And when he came back with having written the book, The Goal, a novel, I thought he'd gone mad, but he was right. I was wrong. It went on to be a bestseller. It's still selling a lot today. 32 languages, 10 million copies. And the crazy thing is, it's still as fresh as when he wrote it, even though we've got new stuff like SAP and smartphones and all that sort of stuff. But what he talks about is still completely relevant, and it's very interesting. By the way, for those who don't know, there's also a more recent graphic edition published in 2017, which is excellent and even faster to read. Right, the book, The Goal, is about 5 hours to read. The graphic edition is only about an hour and a half. So that's really good. If I had to summarize the theory of constraints in one slide, this is it. People assume, have always assumed, that they can distribute the work equitably in an organization, right? You have 20 people here in that department, 25 in that one, in that workshop, in accounting, whatever. That's what people do in budgets, right? They decide how many machines and how many people you're going to put in the various parts of your organization. And you think you've done it, and therefore once you've done it, you can get everybody to work all the time. And that's how we run companies, right? And that's how we do take financial decisions and do all our money counting and all our OEEs, right, to keep everybody busy. Since we have just the right capacity everywhere, then we need to keep everybody busy. And the sum of local optimums is equal to the global optimum. Eddie Goldratt said that's not possible. We can't do that anymore. And probably didn't do it very well even at the beginning of the Industrial Revolution. So somewhere in the system, somebody's got less capacity than everybody else. They've got the short straw in the system, and they are the bottleneck or the constraint in the organization, right? And that means that they are going to control what is coming out of the system. They're going to control the sales or throughput, okay? And all the other resources in the company, right, the 99% of the organization, are by definition non-constraints. They have excess capacity with regards to the bottleneck, and therefore they're going to have to work only according to what the bottleneck or the constraint can do, and have to synchronize the flow of those non-constraints to the constraint, right? And that means from there on that you need to have a dual view. There are two sets of rules, whether it's a bottleneck or a non-bottleneck, and those rules are nearly the opposite from one from the other, right? And so, from once you've understood the theory of constraints, you can't really answer any question until you've worked out whether you're talking about the constraint or the non-constraint, because the answer is probably going to be about the opposite. If you accept that, the way you manage flow, I'll do this very quickly, because we'll be talking about flow management the lean way and the theory of constraints way, right? It's the drum buffer rope mechanism, keeping it very simple, because there's also stuff like simplified drum buffer rope that exists. Okay, and it's based on bottlenecks. Therefore, the drum is the scheduling of the bottleneck, right? It beats the rhythm of the whole company. And then you have the rope, which ensures that you only pull into the system what the bottleneck can manage, and you don't smother the factory in material that can only get into the factory but it can't get out because it can't get through the bottleneck. That's the rope. And then you're going to protect the performance of the bottleneck from variations upstream. If there's absenteeism, machine breakdowns, quality problems, or whatever, you're going to protect the performance of the bottleneck by having a buffer, right? Which is the big difference with lean. We'll talk about that. That first buffer is to protect the throughput or the sales of the company, and then you can also have, if it's your environment requires it, another buffer at the end to ensure your due date performance, to absorb any variability you'll have in performance after the bottleneck. Okay, that's a very, very fast, short summary of drum buffer rope, how you manage flow in the theory. The process of ongoing improvement of the theory constraints, or the 5 focusing steps as it's usually called, right? First thing to do is identify the constraint. The second and the fourth are close cousins. The second step is to better exploit the system constraint. Is what you can do immediately today once you've identified it, without wasting time or spending money. Okay. Then step 3 is to subordinate everything else to the constraint. Right. That's the rope, to keep it very simple. And then if you've done the first 3, you can get to the fourth, which is elevate the system's constraint. Now you can take time, spend money, hire people, buy machines or whatever to increase the performance of your constraint. And if you do that little by little, you're going to break the constraint, right? And it's going to move elsewhere, which means you get to step 5. Hey, it's moved. Go back, find out where it's gone, and you go through the system iteratively. Okay, that's the official version. I could have a whole webinar about just what I've just said about this slide, but let's carry on. The presentation of what is the theory of constraints, this is my personal one. Most people would say that everything on this page is the theory of constraints. I usually call all that Ellie Goldratt's ideas, Goldrattism, because there's the theory of constraints and then this logical thinking, which I've put aside because in logical thinking, there aren't systematically constraints, right? So Ellie was doing 2 different things as far as I'm concerned in his life. One was all about managing constraints, and the other one was about better thinking. So in the theory of constraints, there are the different elements. One of them, historically the best known and probably the most used, is in production, right? And it's implementing what is in the novel The Goal with drum buffer rope and all these sorts of things. Okay. And critical chain project management are the ideas of the theory of constraints on how to manage projects or project portfolios. Very powerful, very interesting, and it's all about managing variability, because I think, for me, the full name of the theory of constraints could have been the theory of constraints, how to manage constraints and manage variability or uncertainty. Anyway, there's a whole chunk of stuff there about how you manage project environments. And then there's the supply chain elements of the theory of constraints, whether it's upstream supplies or downstream distribution, and a close cousin of all that called demand-driven MRP, which no doubt many of you have heard of or have implemented. Okay, and there's some other stuff that needs to be mentioned. Marketing and sales. What happens if your constraint is in your marketing or in your market or in your sales function? Throughput accounting, as it's called, although it's not an accounting system, is how you take decisions based on financial numbers, on dollars and stuff, right? And theory of constraints in services, again, probably a thing that Marris Consulting points out compared to other presentations of theory of constraints, because theory of constraints is not used that much in services. We have our point of view how to do that, but it's often missed out in the presentations of the theory of constraints. So and then logical thinking process. To Eddie, for the 10 or 15 last years of his life, was obsessed with trying to teach the world to think, and he wrote books about it and developed this thing called the thinking processes, right, with many elements inside, which I won't have time to describe in detail today. And then there are probably other elements still to come in the development, right? Because like lean itself, theory of constraints continues to evolve and develop and mature. And then we get to the strengths and weaknesses of the theory of constraints, right? Again, this is my presentation, my perception of it, right? The strengths of theory of constraints is it's powerful, focus and leverage, right? If you get to the constraint and you get it to produce 10% more, the whole company produces 10% more. Everything lights up and it's fantastic, and that means you can get very, very fast results. You'll see some of those in the examples later on. This is again my point of view, another very important, powerful part of the theory of constraints is critical chain project management, because to keep it simple, either you use critical chain project management and you quickly finish all your projects on time, or you don't and all your projects are late and you miss the targets and you don't have the right specs and everybody has a burnout and so forth, right? Anyway, I believe theory of constraints is probably the best in terms of systems thinking with a logical thinking process. But I know I upset somebody even last week at saying that, because it's true that there's some very powerful stuff also in lean scientific thinking, true north and all these sorts of things. But my preference is on the logical thinking process, personally. Visibility, the goal has sold 10 million copies, and that means that a lot of people have heard of that part of the theory of constraints anyway. Okay. And I believe the theory of constraints is more and more pertinent because the world is moving, changing faster and faster, which means you have even less time than you used to be able to distribute the work equitably, and therefore you're getting more and more big, nasty bottlenecks everywhere, surrounded by extraordinary or excessive quantities of excess capacity, right? You don't have time to get rid of your bottlenecks anymore, okay? And finally, in terms of strengths, it's more generic than lean because it wasn't born in a company, Toyota, making cars, and therefore it's easier to adapt it to various environments because it wasn't born in any one particular environment, right? The weaknesses of theory of constraints is it doesn't cover company culture. I know there's things said about that sort of question in the theory of constraints body of knowledge, but I don't believe it does it quite in the same way, as completely or as well as the Toyota Way, and so that's an advantage of lean and a weakness of top. There are no big, long-lasting successes after 40 years, right? The thing that keeps lean honoured is Toyota Motor Manufacturing, because it's still doing it after all these years, and it's there, and it's still making cars and selling cars and so forth, whereas we don't have the equivalent in the world of theory of constraints. We don't have a flagship, right? The name, some say, but then, Six Sigma wasn't very cool. Lean is not very cool. The only one that's worth anything in terms of attractivity is Agile, right? So anyway, theory of constraints, yeah, might have been different. A different name might have helped, but what about the other subjects such as lean? No mature system for identifying constraints if they're not in production. People know how to do it. I mean, with a lot of experience, it's not that difficult. But there's no process, as far as I can see, that enables you to clearly identify a constraint when it's not in production. This one's a nasty one. Quality is basically ignored. The management of quality in the theory of constraints is a non-issue, totally ignored. Then the community has got a proportion of consultants compared to doers that's probably a little unhealthy, and I say this as a consultant, so I'm part of the problem. And there's some confusion about things such as policy constraints or management attention constraints and internal and external constraints. There's still some confusion in some areas, but it's probably also the case in and I think the communities, the theory of constraints community, does not understand lean properly. It's one of the reasons why there's so many issues about putting the two together. Okay. So that was a very, 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 very short presentation of the theory of constraints, and we have a course which you can follow online, and we do that also in Paris or in-house or whatever. So please forgive me, it's hard to summarize such a big thing, the theory of constraints, in less than 5 minutes. That's what I just tried to do. Let's talk about lean, and again, I'll apologize about trying to summarize this thing in 5 minutes is not easy. It comes from the Toyota production system, or Toyota Motor Manufacturing. First its production system, and then more largely it became the Toyota Way more recently. Okay, and it's fascinating to see that it started in cars, but now it is, or parts of it are being used all over the place in all sorts of things, such as hospitals, such as startups, administration, banks, and whatever. Okay, so it's also spreading into all kinds of areas, even though it started in car manufacturing. I'm not going to try and describe the whole of Lean today, just mission impossible, right? So I'll focus on a few things: just in time, Toyota or automation, respect for people, right? But there are lots of other stuff in there which I would love to be able to discuss at length, right? If we take the way, the 5 values as they're presented in the Toyota Way, right? Challenge, Kaizen, Genji, Genbutsu, respect, and teamwork. I won't cover them all, but they're all important. Please forgive me if, because of time constraints, I skip and pick and choose just a few of them today. Okay. I'm going to talk about how you synchronize flows. So synchronizing flow is to keep it very simple in the Lean system, pull, flow, Kanban, or other forms. Okay, Kanban, for those who are new to the subject, is in fact historically a cardboard card that went from one workstation to another, where you were basically asking for material from the workstation upstream from you. Okay. You couldn't use that system just on its own like that, so there are other things such as Heijunka involved to make sure that the load in throughout your system is not too volatile and avoid waves of work, otherwise the system will have a lot of trouble working. And within that just-in-time Lean system, there's something that often is talked about or used is takt time, the rhythm of market demand, which is reproduced within the factory, right? So I make a product every 60 seconds because I'm selling a product every 60 seconds. Okay, again, very, very high level summary. I put this one in among other things because that just happens to be one of my favorite bits of the theory of the Lean thing, and it is called Automation. It's not automation, and it's how to make machines autonomous through automation. And it's very dear to Toyota's heart because that's where they got the money to start making cars, right? And when they were making weaving looms initially, I won't go into the details, but they imagined how one operator could supervise a dozen looms when previously there'd been one person per loom, and therefore they developed the system, made a lot of money with it, which enabled them to have enough money to start making cars. Anyway, and when you think about that, and it's fascinating to see that, you know, even more recently, Akira Toyoda, for instance, was saying it in 2020, it's all about workplace and thinking as if you work there, and nearly every important bit that's come out of the theory of the, I'll say it again, everything that's come out of Lean comes from the shop floor, basically. Pillars of Lean, respect for people. I could have a week's discussion about this, and the inverted pyramid. That's to say that the people who are actually going to give you all the ideas and that's where all the brain power is, and the suggestions can come from the frontline workers. And in fact, everybody else should just be helping them, supporting them, right? The management should be there to enable all those ideas and all those improvements initiatives to happen. And that's the inverted pyramid of the Toyota Way. And it's easy to summarize like that, but it's very, very, very rarely observed outside of Toyota. Same slide, strengths of good Lean and weaknesses. Well, it works, and it's been working for a long, long time, decades now. The respect for people is completely integrated in the system, right? Apart from all the technical things like Kanban and SMED and whatever, it's right there in the heart of it. One point which I think is kind of undervalued or under-recognized is Lean engineering, how they design their cars, okay, that are easy to produce and to use and are reliable. Unfortunately, not often copied or implemented outside of Toyota. Quality, unrivaled quality results. They're just, you know, on another planet in terms of their results and their attitude to quality. The body of knowledge is now fairly clearly written up and coherent. Supplier partnerships, I've mentioned it twice because I don't understand why nobody decided to copy that part of what they do. It's quite easy to implement. It just takes patience, which maybe is why people haven't done it. and it's part of their success, because they only make part of the value added of a car, right? A lot of it comes from their suppliers, and they've got the right suppliers because they've developed partnerships with them. A community where there are many more doers than consultants, and in good lean there is a permanent search for growth, so that growth is superior to productivity, and you therefore avoid layoffs, right? We'll come back to that. Weaknesses of lean. 95% of cases are bad lean, a process of continuous downsizing using Japanese words, right? That's the problem with lean, is basically that there's so many bad lean examples that it's got itself a bad name, right? There's also the number of companies that think they've already doing lean when they haven't got less than 10% or maybe less than 1% of what really is involved in doing lean. The origins to some manufacturing cars means that as further you get away from that, the more difficult it is, and the more you have to adapt the ideas of Toyota to your business, right? Whether it's less repetitive or non-repetitive production, whether you have inherent variability in your takt times or your execution times on a particular stage, or whether you're in process industries or industries where you have machines you can't stop, or you can't do one-piece flow and all these sorts of things. Anyway, patience. The results take a long time before you get the results, and Toyota's been doing it for 7 years now. And people differ about how you get started or how you keep it going between 5S, 5Ys, VSMs, respect for people, or whatever. So there's some confusion of where to start and how to do it. And in exactly the same way as I said that theory constraints people are not very good at curiosity in terms of understanding what's happening in the lean world, well, the lean purists are not interested in what's happening in the theory constraints either, right? So they don't understand what that is, hence a lot of confusion. We're very lucky to have in France a factory, Toyota Una, with 5,000 people, which means we stay tuned on what good lean looks like, since they're producing a third of the cars in France these days, and they are quite remarkable. And we have the pleasure and honour of having the ex-vice president of production as a partner in our organisation. He's the one who does all the training about lean, whether it's the online course or the in-house or the in-person training that we do here in French. And there's, by the way, a new the next session in French, en français, à Paris, is on the 23rd of May. And just checking, the combination, excuse me. I'm going to argue that there isn't much difference between the two. I guess that's going to shock people. I hope that will provoke lots of interesting questions and discussions. Often it's just a question of vocabulary, right? Both of them have exactly the same obsession with improving flow all the time, the time it takes from the beginning to the end, and so forth, right? And they both just say the same thing with different vocabulary, but they're doing exactly the same thing, right? So words such as avoiding overproduction, right? One of the wastes is the rope of the theory of constraints. Scientific thinking of lean is logical thinking in theory of constraints, etc., etc., etc. I won't describe why in detail the differences are. It's partly because push and pull flow. I'm not sure even I've understood the difference if you think hard about it. But they're trying to improve flow, right, and trying to work out the right thing to be done at the right time at a machine. And the other thing is that in both cases they are trying to increase sales while reducing lead times and reducing expenses. The problem is that everybody doing bad lean has missed out the part about increasing sales, right? So they're just firing people all the time. But if you combine the two together, the theory of constraints can help you determine what to change, what's your bottleneck, what will enable you to increase your sales. And then you can use the lean tools to improve that performance of that constraint, right? And if you do that, just focusing side, get to a point where you can't add any more people to improving the constraint, right? Imagine you're a 500-person organization. You can't actually have 500 people working on the constraint at any one time or improving the constraint. And so the people, once you've focused on improving the constraint, right, and you've got people working on the constraint, and because it's what is going to help you produce more, everybody else can continue doing improvements, which would be by definition on non-constraints. They just, on these non-constraints, shouldn't be trying to increase productivity as such because they can't produce any more, right? They are not the constraint, but they can reduce waste, right? By dealing with quality problems, flexibility, and so forth, right? So the rest of the organization can be improved simultaneously. To my mind, Eddie Goldratt was saying exactly the same thing. After all, go back to the goal. The goal is to increase throughput and simultaneously reduce inventory and operating expense, right? So again, it's just a question of vocabulary whether you agree or not. I mentioned it earlier, it's an obsession of mine, sorry. Why do people not take into account the lean partnership, the long-term partnerships with suppliers? It's very easy, it's proven to work, and with the factory here in France, it took them 10 years to set it up. For the past 10 years, they haven't changed any suppliers. So when you mix theory, constraints, and lean, as far as I'm concerned, please do take the long-term partnerships with suppliers part of lean and add it to your cocktail. It's just crazy not to do it. I don't know why. Nobody does. In the cocktail of TOC plus lean, I would heavily recommend that you look at critical chain project management because that enables you to do your projects faster and on time, and combine it with lean engineering, which will make sure that the products you develop, if you're in product development, are better products, easy to produce, go through the factory easily, and so forth. Okay. Thinking. You've got the goal tree of the logical thinking process, which I love, and all the tools of the logical thinking process. For those that don't know it, have a look at the book on the subject, or the videos on YouTube. And when you look at what's happening within the lean, especially maybe the last 10 years, there's more and more about scientific thinking about how people think in the lean world. And when I talk with people about Toyota and how they hire people, it's crazy how much time they spend about how good the people they're hiring, how good they want them to be able to think and do problem resolution, 5 whys and stuff. So thinking is very important to both sides. I don't know why it's led to a confusion about the differences. And we get to the only real difference here, right? Which is about to buffer or not to buffer. Am I allowed to break the one-piece flow rule and have piles of stuff in my factory? Lean says no, theory consensus says yes, okay? And I still maintain, that looks like a big difference, right? And it is, but it's confusing because they're both trying to do exactly the same thing, right? And if I add that if you put buffers in your system, as the theory of constraints recommends, okay, as long as you don't fall asleep on those buffers, that's to say that you have the obsession of reducing those buffers by getting rid of what made them necessary, the upstream variability, then you're basically very, very close, lean and theory of constraints, right? Because you're both trying to get to infinite speed with a minimum amount of inventory. You're just not doing it the same way. The theory of constraints buffers it, and there's a risk that you then get lazy and live with your imperfections, whereas the lean forces you to improve by having very, very little inventory in the system, and therefore, because there's very little protection, it means that you're going to have to solve the problems as they occur all the time. So we'll probably lead to discussions at the end in the Q&A on this point, because this is, for me, the one and only real difference between the two, and it's only an apparent difference because they're both trying to get to the same minimum inventory in the system. A few implementation examples. Production of rockets, the Ariane 5 rocket, so this is a couple of years ago, and they had to ramp up, go from 6 tanks and 6 rockets to a year to 8. We had a look. It's often the case with the theory of constraints, right? You you focus down into the system, so there was an overall lack of rockets. The lack of rockets was because of lack of tanks. The lack of tanks was because of initially the big specific welding machine, and so we identified it using the theory of constraints, and then we improved it using lean tools, and in this particular case, the mascot of critical chain, but then lean operations throughout the manufacture of these tanks. And we broke the first bottleneck, went to the second bottleneck, went to the third bottleneck and stuff. You can have a look at the video, which gives the whole story there by the people from Haiyan. And so the target was achieved. In fact, they overachieved, since they got to their 8 tanks per year, but simultaneously they managed to go from 3 shifts to 2 shifts, right? So an increase in 60% in productivity in that production by mixing in theory constraints and lean. Another case, which is in a very, very lean organization in Mexico, a 1,000 person factory making alternators. Really a very, very lean organization, one of the first to adopt lean back in the 1970s. And the demand had just spiked for their products, and so they had trouble ramping up, and they were getting late. And so they implemented the theory of constraints to increase the output. And this managed, an example of the speed of results you can get, but it is our record. I don't think we can probably go any faster than that. By implementing the theory of constraints on the 1,000 person factory, in 15 minutes we increased the throughput by 17%, because the constraint had been properly identified. We buffered it. With 12 parts in front of that, and that absorbed all the micro stoppages that were happening due to problems upstream, and that led to a huge increase, or a big increase, in throughput. Okay. This is I wanted to put some fresh stuff in. So this is stuff that slide I wrote this morning, because it's a job we did in last month in March 2024 in the USA, producing medical devices, 1,000 people, another 1,000 person factory, high volume production, 100 million units a year. Okay, but not meeting demand, the delivery backlog and increasing. So problem with meeting demand. The bottlenecks, they weren't very clear exactly where they were, but it was confirmed that the assembly lines were the bottleneck. And in those assembly lines, when we looked, it was again one-piece flow in the system with no buffering of the constraint within the assembly line. I remind you, it's a bit like you have various levels, right? The bottleneck was the assembly lines, and in the assembly line you look into the assembly line, you find the bottleneck within the assembly line, right? So within the assembly line there was one of the operations that was the bottleneck of the assembly line, and it wasn't buffered, it was in one-piece flow, and so we again buffered it, and that increased significantly the production of the assembly and therefore of the 1,000 person factory. Here in this case, in fact in both cases, the previous one and this one, the problem that they weren't managing the work in progress properly, or you get the impression some people think that, you know, the less work in progress you can have, the better you are. And in this case, they had pallets that supported the product as it went through the assembly line. Okay, and there weren't enough pallets in the system. There were less pallets in the system compared to what the design had been, because some of them were broken and were being repaired, and therefore there was even less inventory in the system than they designed in initially. So it was just, you know, bleeding stoppages. So just adding just a little bit of inventory back into the system got the OEE back up remarkably. So I wanted to put this one in because, you know, it's just what I call dogmatic lean. Okay, dogmatic lean is your zero inventory is the answer, or one-piece flow is the answer. What is your question, sir? And when you look, you think to yourself, I mean, that's machine's stopped because there's no inventory in front of it. And this happens much too often. Maybe there'll be questions on that one. An aeronautical manufacturer of flight control systems. And you can have a look at the videos, many videos on this particular example in the Safran group. We increased the rate of the bottleneck, which was quality control. By the way, watch out, quality control is often the bottleneck in modern factories. We did a lot of lean stuff, single minute exchange of die and all these sorts of things. We also implemented the 2-for-1 rule, which is neither lean nor theory constraints. To reduce the inventory in a system, you ensure that there is more that goes out than comes in, and so you have, for instance, 2 work orders have to leave the system before you're allowed to launch a new work order in. That's what we did with them anyway, and that worked very well. As a result, output and productivity increased significantly. They caught up their backlog, and they got back to a really good service performance. And another completely different environment here. This is the world leader in fast food. 1,500 restaurants in France, 70,000 people. Had trouble delivering sufficiently fast the new system where the food was prepared when the client ordered it rather than by anticipation to make sure that it was fresher. And this would reduce the productivity and service level of the restaurants. And so we did a quick diagnostic, one-day diagnostic, identified the bottleneck, and in this case we didn't even try to manage it. We got rid of the bottleneck by making sure that there was a full kit of food being produced. That's to say that they worked by customer order rather than local optimums saying, you know, let's do the cheeseburgers first and then those hamburgers and whatever, because that was destroying the completeness of the orders coming out of the kitchen, and everybody was going crazy and all these sorts of stuff. By doing that, the service times of the 1,500 restaurants went down by 60%, but also other remarkable stuff like, you know, the material waste was divided by 10, and there was a big impact on profitability and other stuff. Anyway, I could go on like this for hours because we've been doing this for about 30 years, 300 times. Have a look, for those that don't know, have a look at our YouTube channel. It's got 600,000 views, 460 videos right now, and a lot of them by our clients, so you don't have to take my word for it. And there's one video, for instance, if you want to start off and you feel you want to hear more about examples of theory of constraints and lean, is that there's one video which has 15 examples, which we did recently. Okay, so let me conclude. As a conclusion, I think all I can say about this is, you know, I've been mixing those two things in all my life. I repeat, I discovered the lean first in the first 6 months of my professional career, and I've been trying to implement it ever since in all kinds of environments, and it's fantastic. I'm still learning, and so it's really very, very powerful. But then a little bit later, I discovered the theory of constraints, and I've never understood why people, you know, keep saying you have to choose between the two, because I've been, you know, doing a combination of both of those all my life. Now, you might have some questions coming up about, you know, when do I use more lean, when do I use more theory constraints, that sort of stuff. But I certainly think it's a big pity that there's basically a fight going on between the lean community and the theory constraints community, and people are asking you to choose, when I don't think you have to choose. You can perfectly well combine them. That's what I've been trying to explain in this webinar. Okay, so that's that. If you want to, this is the advertising page of this webinar, right? If you want to learn more, we have online courses in English on all the subjects I've been talking about: theory constraints in production, good lean, bad lean, critical chain project management, logical thinking process. There's some online training available. So go to our website and see that if you're interested. You can also come to our in-person courses in French if you speak French, or you can learn French and then come to the course. It's in Paris all year round, and have a look at our program to see when the next sessions are. Of course, all this training we do in-house all over the world, on all the continents, and we love traveling and repeating all that in your factories. We also have a reputation of being able to do very good short 2-day diagnostics if your factory is, let's say, less than 800 people, or maybe 3 or 4 days if it's more than 1,000. And we conclude on the afternoon of the second day on our findings, where the bottleneck is normally, and what the action plan to implement zero constraints and lean would be. Okay, and even more successful than that, quick 2-day course is 2 days plus 1 day of training, where the following day is a personalized training where we say, if that's the action plan, these are the ideas you need to have, this is the training you need to understand, whether it's single minute exchange of die, or the 5 focusing steps, or whatever, or Taguchi, or whatever. Okay, so that's it, and enjoy the cocktail of zero constraints and lean. Thank you very much. Bye.